Okay, so we have another question here. It says there's a game called darts, and dart has been thrown at the dartboard, and we can see that this is thrown at the velocity this and at angle this, and it travels this much horizontal distance, and just before it hits the dart, the vertical component for that particular velocity, for the final velocity, is 0. The air resistance is negligible. The time taken for the dart is this. You need to find it out. So what we have final velocity, right? And we need the vertical component for we have the vertical component of that final velocity, right? So which is 0 meter per second. Okay, now in order to solve this, get some information from this, we will use the vector diagram to get the values, right? To draw the vector diagram is very simple. This is your resultant line, as you can see, which is 15.6, right, at an angle this. So how will I get to this destination? It's simple, right? We usually call this head to tail rule, right? So you can only go left, right, up and down, right? So how will you do it? How will you get to this diagonal directions? You will use the left direction and then you will go up, right? So it's basically the same thing as head to tail rule. Your first line, this is your second line from the head of the first line, and your resultant line starts from the first line's tail to the second line's head. That's simple, right? And then this is your angle, this is your right angle right here, and opposite to this angle, which is 5 degree, is sine theta. And to get the cos theta, it's very simple. Choose that line which is not the resultant line, which is this is the resultant line. Don't choose this as your cos, choose this as your cos. Okay, it's very simple. So now what we need to do is, as you can see, we have vertical components right here. Okay, so what we can do is we can also get the initial velocity in vertical component as well, right? Because we already have vertical component final velocity, we can get the initial velocity for the vertical component again. So if you get it, is u is equals to 15.6 at which speed it is going and at which angle it is going. It's going at sine 5 degree angle. Okay, so if you multiply it, you will get 1.3596 blah blah blah, and if you round it off, you will get 1.36 meter per second. Use this value rather than this value to get to use it for another calculations. Not use this because it will cause some errors. Maybe there might be some answer difference in your final result. So yeah, now let's see what formula or equation of motion we can use to get the time, right? We have final velocity, we have initial velocity for that vertical component, and we also have acceleration because in vertical component you have a gravity acting against you, so it's acceleration 9.81 meter per second square. Now whether it's positive or negative, you have to be very sure about whether your answer is positive or negative because it can affect the final result. Okay, so as you can see that if you can see this direction, it is going up but our gravity is down, right? So you have to choose one of them, like if you want up as positive or down as negative, right? If you take up as positive, then your sign, this initial velocity will be positive but your acceleration will have a negative sign, and if you do the opposite, then this will be negative and this will be positive. Okay, so now let's go. So we can use this formula, which is v is equal to u plus at, one of the equation of motions, and you have your vertical components. Remember the vertical component, right? So it's 0 is equals to u, which is 1.36, not 36596 blah blah blah, and plus 9.81, and you basically times it with t. Okay, so if you rearrange t, you will get 1 point a negative. My bad, I forgot to add negative again. So this will get over here and become negative, so it will be negative, let me go a bit more down, sorry, negative 1.3596, and then this will be divided by this, so it's negative 9.81. So negative values will give you, let me calculate it myself as well so we don't make mistakes, right? So it's 1.3596. Yes. So I get around 0.138 blah 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 blah. I think it's I think after that it's 5 for me. It's showing 5. Maybe it's showing something else for you. Maybe I don't know. I might have made a little bit of mistake there because I didn't write full value. I just write 1.3596 and didn't write the rest of the value. But you should. Okay. I'm just doing a sample calculation here. Okay. So if you round it off, you always have to give your final answer as a rounded off answer, right? So let's see what values or how much round off they did. So as you can see, they took one decimal place or three significant figures or sometimes two significant figures as well. So let's take three, okay? So it's like 1.39 meter per second. Even you can take 0.14 meter per second. Sorry, not, oh my bad, this seconds, my bad, seconds, okay? So you can either take one of these depending on what significant you use, okay? So basically this is your final answer. Okay, so the next part says that calculate the horizontal distance traveled by dart. Okay, so now we are only talking about the horizontal part, right? So let me draw the vertical component again, right? So as you remember from the previous part that the vertical component is drawn like this, where there is sine theta here, cos theta here, and it was 15.6, right? Meter per second going in for 15.6 meter per second. Degree was 5 degree angle. The angle was 5 degree. Okay. Now we are only talking about the horizontal component, which is now the cos part, right? So the initial velocity is 15.6 at which speed is going and at which angle it is going. So cos 5 degree angle. Okay. So now if you multiply this value, you will get 15.540 blah blah blah. And if you round it off, it will be 15 point, let's say 5, yeah, meter per second. You use this value, not this right now. Okay. So now what we will do is we need to see which of the motion equation of motion that we have to use in order to solve this question, right? So we have initial velocity and our acceleration will be 0. Why? Because meter per second square. So because see, as you if you have read the last part's question, right, it said that the air resistance, right, was negligible, right? So there is no air resistance at all at any directions, right? And there is also like gravity acts only in the vertical component, right, not the horizontal component, right? So there's nothing in the horizontal that is giving it any resistance or anything else. So we say that the velocity, if acceleration is 0, the velocity is constant, right? So there's no changing acceleration. So now if we take that part, we have acceleration and we have initial velocity. We can use, and we need d, right? So and we also have time. Main thing, we also have time, which is 0.139 that we calculated, or 0.14 if you want to see that. So t we also have. So now we can use the equation of motion, which is s is equals to ut plus 1 by 2 at square. So your a is basically what? 0. So now you're left with s is equals to ut. Now your s is basically d and your u is 15.540 and blah blah blah. If you times it with 0.139, I don't have the value written right now. I have only the answer written. So if you have the calculated value of the time, use that. Okay, it's something was 0.138 blah 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 blah. You will use that and you will get, I got 2.160 blah blah blah, something like that. If you round it off, you will get 2.16 in three significant figures, or if you want to write it 2, you can write it 2 as well. It could be 2.2 meters as well. Okay. So basically this is your final answer.